Thank you very much for joining me tonight. This is an introduction to the Python programming language presented by the IEEE's Florida West Coast Section's Computer Society. I am Dr. Jim Anderson, and in a very brief time, a little bit less than an hour probably, I'm going to do my best to introduce you to a relatively new programming language called Python. So let's get started, shall we? So, gotta have goals if you're gonna have a presentation, and I've got a few of them for this one. So what do we want to accomplish tonight? First off, obviously, I want to introduce you to the Python programming language. I'm not gonna make any assumptions about previous programming experience you might have, okay? Number two, I want to show you how you can install Python on your home computer. So if you get excited about what I present to you tonight, if you'd like to move forward with it, if you'd like to, so to speak, get your hands dirty, I want to show you exactly how you can go about doing that. I want to explain in the world of Python how variables work. It's sort of, one of the key starting points. I want to explore how to get input from a user, and then how within a Python program you can produce output so you can show the person who's running it what you're thinking. I want to show how you can control your program flow, basically make decisions. I want to introduce the concept of a list and what can be done with it. A list is really sort of a fundamental concept in the world of Python. So we'll take a look at it and we'll explore what you can do with lists in Python. Then we'll explore some functions, and we'll talk about how you can use functions in Python to organize the code that you're creating. That's it. Got 7 goals. Let's see if we can make it happen. Now, Python, interestingly enough, is a programming language. Yay! Programming languages are used to create software. And literally, there's no shortage of languages out there. There's a lot of them. Okay? Computer programs, known as software, are simply instructions that tell a computer what to do. You use a programming language to create a computer program. Okay? And there's a lot of different ways you can go about doing it. Why are there so many different languages? Well, because each one of those languages has been designed for an explicit purpose. It was designed to do something very, very well. Okay? And so depending on what you're doing, you'd probably want to choose the right language for the task. The nice thing about Python is that it does a lot of different things really good. All right. So just here's a quick snapshot of the current view of the world, so to speak. There are a lot of languages out there, a lot of languages being used for doing different things. You've probably heard of Java. Java's a little bit everywhere, stuff like that. A bunch of other interesting languages. JavaScript is another popular one up there. C#, which is a language that was invented and has been promoted by Microsoft, is up there and stuff like that. But note, number 1 on the list is Python. So right now, as we're speaking, Python is the most popular programming language out there, okay? And that's why we're having our program tonight, okay? I want to introduce it to you. I want to make sure that you understand what Python is, what it looks like, and most importantly, what you can do with Python. All right. So what are we going to be using in this presentation? Well, potentially you can use your laptop, and of course you can use the Python language. The best thing about the Python language is it's free. Doesn't cost you a thin dime. Okay, where did Python come from? Great question. It turns out that it was conceived late 1980s, so that's a little while ago, by a gentleman by the name of Guido van Rossum, and he lives, interestingly enough, in the Netherlands. So why did Guido make the language? Well, he had a boring job. His job was to keep a whole set of servers updated, which meant every single night he had to go out to each and every server and make changes to it. And very quickly he realized this was a grind of a job, and he wished that there was a way he could actually maybe program it so that he didn't actually have to do it. So he took a look at the languages that were currently available in the late 1980s that would allow him to do this, and he wasn't really happy with what he saw. He didn't find what he was looking for. Okay, so he did exactly what anybody would do. He wrote a language. He created Python. Okay, now interesting characteristics of Python from day one. It didn't really have to run fast. He wasn't looking for blazing fast speed. What was much more important to him was that he could change his programs quickly, because his job of updating all those servers changed every night. Okay, and he wanted it to be easy to document, so he could take a look at code and figure out what it did so he'd know where he needed to make changes. And those characteristics are still part of Python today. He designed a language, made it very easy to work with, complex data. Hot diggity. So, what is Python? So, Python's a widely used general purpose, high-level programming language, which means it's easy to use. Its design philosophy is all about code readability. When you look at a Python program, it's pretty easy to figure out what it's going to do. And it doesn't take a lot of lines of code to write a program. If you were programming something in a different language, such as C++ or Java, it would require more lines of code than it takes in Python. And there's a variety of reasons for that. But Python's relatively compact as far as the code that you actually have to generate. There's a whole bunch of different ways to write Python programs. We're just going to cover one tonight. But if you wanted to go crazy, wanted to go object-oriented, not a problem. Python would support you. Okay? So it's very, very, very flexible. So why do people like Python? Well, first off, it's got a simpler, cleaner syntax than a bunch of the other popular languages out there, and that makes it easy to learn. You can try out short Python programs in an interactive environment and get quick feedback on whether or not your program works. Okay? And it's super portable. No matter what type of computer you have, be it a Windows box or an Apple box or even a Linux box, not a problem. You can get Python to run on it. So it's not a problem whatsoever. And if I write a program on my Windows box and you've got a Mac box, I can give you my program and you can run it on it, no problems. So let's get you a copy of Python. By the way, I'll make all of these slides available to you after tonight's presentation is over, all right? So you can write it down or you can just get a copy of the slides. You'll need to go to a website, www.python.org, okay? And there, you'll see a screen that looks like this. In the upper left-hand corner, you'll see that you can click on Downloads. When you do that, it's going to say, hey, would you like to get a copy of Python? And you'll say yes. I took a quick look the other day. I believe the current version is 3.10.4. That'll change over time. Don't worry about it. As long as it's a 3, you're all good to go, okay? You'll get the latest and greatest version, bring it down to your laptop, install it, and you will have Python. Now, after you install Python, what you're going to discover is you've got a whole bunch of interesting manuals and stuff like that that get installed on your computer. But what's also interesting is you get a program called idle that'll be installed on your computer. And I think I have idle here, so let me just take a look. Boop. I'm running my version of idle right here. Boop, doo, doo, doo. Let's see if I can move it over to the side here. So idle is just a little program that comes along with Python, and basically it's designed to allow you to get started in programming in Python. So I'll just show you, we'll talk about these statements here in just a little bit, but I could do, just to have a little print statement. If I hit enter, it actually executes that statement. I can do some other stuff where I say things like equals 5, equals 10, print A plus B, oops, A plus B. How about that? That's better. Poof. So I can actually get Python to accept my commands and immediately execute them. That's what idle does. So it's designed to be an interpreter. So if I have a thought that I want to test out, I can go straight into idle, run it, and it'll tell me what's going on. Okay? IDLE stands for Integrated Development Environment, but the reality of the situation is the guy who invented Python really, really liked Monty Python. And Eric Idle is a member of the Python cast, and so he decided to name part of the Python language after him. So this is what I just sort of showed you. It's an interpreter. So basically, if you type in Python commands, it will immediately execute them. It turns out that IDLE also allows you to open up a file, and you can type in commands, and then you can say, hey, run them, and it'll go off and run it. So you don't always have to interpret all of them, but you can do it either way. So idle's nice. It's a convenient tool, and it comes with Python. So the moment you install Python, you have that available to you. So let's talk for a moment how Python works on your laptop. So you're going to create basically a source file. Fantastic. You're going to type out your Python program. Great. You will then submit your source file to the Python interpreter, basically a program that runs on your laptop. What's going to happen is it's going to take your source file and it's going to compile it. It's going to turn it not really into zeros and ones, but something that we call bytecode. So a super condensed version of your program. That bytecode is then going to be submitted to a virtual machine, which is simply a program that's running on your desktop. The bytecode goes into the virtual machine. The virtual machine might reach out and bring in some library modules at the same time, but then it's going to go through that bytecode and it's basically going to run your program. It's going to produce output and it's going to show you the results of your program. So that's how Python works. Couple of important points here, okay? Python interpreter translates your code into bytecode that gets executed by that virtual machine. It never turns your program into zeros and ones that your CPU can use. That's the responsibility of the virtual machine to talk to your CPU. So what that means is you never create a Python program that you can just take from computer to computer to run. You always take your source code to another computer, run it through another Python interpreter, another Python virtual machine to get it to run. So Python does not produce executable programs. You always have to have your Python interpreter if you want to run your program. Big deal? Not really a big deal. It does mean that Python runs slower than some of those other languages that allow you to produce an executable. All right, so if you like Python, and if you install Python on your computer, that's great, but there's another piece of software you're probably going to want. This one's called PyCharm. You can get it from www.jetbrains.com/PyCharm. And what it is, a fancy term for it, is an IDE, or an integrated development environment. Basically, it's an environment that lets you write Python programs. It does nice things as far as like making your keywords different colors. It'll do error checking for you, allows you to do debugging, all sorts of fancy stuff. It's a great way, great environment, almost like a word processor if you want to think about it that way, like Microsoft Word for writing Python programs. I'm going to be using it tonight, so you're going to see a fair amount of it, okay? If you get PyCharm, you will want to actually get the Community Edition. There is a Professional Edition, so if you're doing Python professionally, you could download the Professional one and pay for it. Thank you very much. Community Edition, of course, is free. All right, let's talk about problems. I need to know what's going on in my program. I need my program to be able to talk to me. So I'm working on a loan program. How much is the loan going to cost? How much inventory do we have left over? How many chemicals have we used to make a mixture? How many artifacts have been collected? All sorts of great things that the computer knows about, but I need it to be able to tell me. So how can I do that, and how can Python help me do that? Well, Python has a statement. The statement's called the print statement, and anything you give to a print statement will be displayed on your screen. So it goes print, left parenthesis, and then anything in between the parentheses is going to be displayed on your screen. Okay, and I think if I do this correctly, I have an example here. Boop, here we go. So hopefully you can see on the screen. This is, by the way, this is PyCharm. So I've got print, and I have double quote, hello world, double quote. So I'm going to display hello world on the screen. Now I have print 2 plus 6, and not to be 8. And then finally, I'm combining letters and numbers. So I'm going to do print, double quote, there are, double quote, comma, 7, comma, double quote, days in a week. All right, I want to run this program, so I'm going to go over to the left here. I'm going to left click on my mouse. I'm going to go down to where it says run, and the name of the program that I have is print. I'm going to say run print. And then down here in the bottom, when it gets its act together, because sometimes my computer takes a little while to run things, so we'll give it just a moment, it should display the results. Pow! So it printed hello, which is good because I had print hello world. It displayed 8, good, because I asked it to display 2 plus 6. And then it said there are 7 days in a week. And I had said there are 7 days in a week. So it looks like it did exactly what I wanted it to do. And it's the print statement. So anything you give to a print statement will be displayed on your screen. Well, that sounds pretty good. So we're happy about that. Now, in a Python program, you can also have comments. And comments, surprisingly enough, they're not executed. The computer actually just throws them away. Any comments, it's just going to completely ignore them. But they're actually really, really important to you as a programmer. And the reason is because after you write a program, when you come back to that program in a year or 2 years or 3 years, and you look at it and go, wow, what was I thinking? Comments are how you can talk to yourself. So it's a really good idea to put comments into programs, okay? In the world of Python, comments are anything that occurs after a hashtag, okay? Comments in programs start with a hashtag, extend to the end of the physical line, okay? It can occur at the beginning of the line, it can occur halfway through the line, doesn't really much matter. If it occurs within any of those double quotes, for example, if you're doing it in a print statement, it will not be considered to be a comment. But if it's assuming it's not within a print statement, Python will always assume anything that comes after a hashtag is a comment. All right, we're going to write our first program. Traditionally, in the world of computer science, we always write a hello world program, so it's pretty simple stuff. So let's see how it goes. We got to remember, Python is case sensitive. It cares about upper and lower case characters. You must enter upper and lowercase characters correctly. In our world, the word print is all lowercase. That means you cannot do capital P for print or all capital letters for print. Those will be interpreted as something else. If we want Python to print something to our screen, we have to do it all lowercase. So bam, there's our first program. And not to get too excited, but I think I have a copy of that. So let's take a look. There we go. Here we go. Notice that my first line is a comment, hashtag, my first Python program. Remember, that's for me, okay? Python throws that away and says, it's a comment, I don't care. First line in our program is print, left paren, double quote, hello world, double quote, right paren. If I run this one, so I go over here, say run hello world. Oh my goodness, what's it gonna do? What's it gonna do? Give it just a moment here. Boop, there we go. It printed hello world. It did exactly what I was hoping it was gonna do. Remember, print displays something on your screen. All right, so we're good to go with that. We've written our first program. Let's move on now. Now we're going to talk about variables. All right, so what do we got going on here? So variables are simply reserved memory locations, and we reserve them so we can store things there. That means when you create a variable, you reserve some space in the computer's memory, and the good thing is you don't have to remember where that space is because we can give it a variable name. Variables in Python are consist of an alphanumeric name that begins in a letter. Variable names are case sensitive. That means if I had a variable called scores, all lowercase, it would be different than if I had a variable that started with a capital S, scores, or all capital letter scores. Now, all three of those, scores, scores, and scores, are very valid variable names, but those are three different variables. Python variables do not have to be explicitly declared. I can just use them. Anytime I think of something, I'd like to store something, I can just stick it in a variable. Other languages require that you tell the language about a variable before you use it. Python's like, nah, don't worry about it. Just stick something in there and I'll take care of creating memory for it, okay? Operand to the left of an equal operator is the variable name. Operand to the right of it is whatever you want to store into it. Some examples of variables are in the lower left-hand corner there. Counter equals 100. Counter is a variable. Miles equals 1000.0. Miles is a variable. Name equals double quote, John, double quote. Name is a variable. Variable names can be infinite in length, but you want to be a little bit careful there. Don't make them too long. So in Python, I think there's 6 types of variables. What do we got? We've got integers. Now, integers are counting numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8. They don't have a decimal point, which is in contrast to floats. Floats are decimal numbers. They have a decimal point. 3.14, 7.3, 100.123. Those are called floating point numbers. Now, strings in the world of Python is a contiguous set of characters represented in quotation marks. Interesting enough, in the world of Python, it allows either single or double quotes, and it's exactly the same. So double quote, hello world, double quote, fabulous. I could also have single quote, hello world, single quote. The only thing with the single and the double quote, if you start with singles, you got to end with singles. If you start with doubles, you got to end with doubles. One other type of variable we have are called Boolean variables. These variables can only hold 2 values. One is true and one is false. And you can make it either way, but those are the only values that it can hold. Now, there's another type of variable called list, which we will be talking about tonight, and one other called dictionaries that we won't have a chance to talk about tonight. But those 6 variable types are all the variables that Python can hold. I apologize because I'm actually cheating here. There actually is one more, but it's so freaky weird I don't talk about it. Python can handle complex numbers, but I still haven't quite figured out why you would use complex numbers on a normal day. So it's there if you need it. Now, one type of variable, of course, is Boolean variables. So let's talk about that for a moment. Sometimes you need to evaluate a logical condition in one part of a program and then end up using it later on. To store that condition, which can be either true or false, you use what we like to call a Boolean variable. In Python, a Boolean variable can take on one of two different values. It's either false or true. Now note that in the world of Python, we capitalize false or true. So it's capital false and capital true. That's important. These variables are not strings, they're not integers, they are just very special values, and we only use them for Boolean variables. Here's a quick example of what's going on. So I could have the variable called failed, and I could load it with the Boolean variable true. Note the capital T. Later on in my program, I could say, yo, did I fail? If failed, does failed equal true is the question. If so, then I'm going to go off and do something. Okay? We have Boolean operators too. When you make complex decisions, you often have to combine different Boolean variables. An operator that combines Boolean conditions, we like to call it a Boolean operator. So we've got a couple of them. One is and. Okay? True only when both of the conditions are true. We also have an or. And an or operator is true only if at least one of the conditions is true. So here's a little example. X is less than 5 and x is less than 10. So if x was equal to 4, for example, both of those conditions would be true. We also have x is less than 5 or x is less than 4. So if x was 5, it would not be less than 5. Stop, did I get that right? So if x was 4, that's better. So if x was 4, it would be less than 5, but it would not be less than 4. But that would still be true because one of the conditions was true. Now, one other operator we have is not, and all it does is reverse it. So if we give not a true, it gives us back a false. And if we give not a false, it gives us back a true. And I think I talk about that here, inverting a condition. If you need to invert a condition, that's what not is all about. So not operator takes a single condition, either true or false, and it evaluates it to true if it's false and false if it's true. So if not frozen, print not frozen. So if the frozen variable, which was a Boolean variable, contained a true, then that would be turned to false, okay, which means it's frozen. If frozen contains a false, that not would turn it to a true, and we would go ahead and print out not frozen. Logical operators, once again, some examples here. If I wanted to go buy beer, if age is greater than 21 and I have my ID, then I can buy beer. Otherwise, no buying beer. If I'm hungry or if I'm bored, I'm going to eat. Otherwise, I should probably go running. And if I'm not older than 65, okay, then I can't get any Social Security. So just little examples of how we would actually go about using logical operators. In the world of Python, if we're going to do anything with letters and characters and stuff like that, then we're going to be doing something with strings. Computer programs will have to process text in addition to numbers. Text in the world of Python consists of characters, letters, numbers, punctuation, spaces, and pretty much anything you can find on your keyboard. A string is simply a sequence of characters. For an example, double quote, John Smith, double quote, is considered to be a string in the world of Python. So, how do we deal with strings? So, strings can be stored in variables, so the variable answer takes on the string a, lowercase a. A string literal, in other words, if we use it in our program, would be double quote, Mississippi, double quote, okay? In Python, string literals are specified by enclosing by either single or double quotes, and there's a little example there, double quote fire truck or single quote fire truck. Python treats both of those exactly the same, no difference between them, okay? But remember, if you start with a double quote, you got to end with a double quote. If you start with a single quote, you got to end with a single quote. In Python, we can do math. Yay! You can see our operators here. We've got plus, we've got minus. The star means multiplication. The slash means division. The percent, something you might not see every day, is modulus, which basically means if I'm doing a division, what's the remainder? So 5 divided by 2, remainder is 1. Star star is exponentiation, so 2 star star 3 would be 2 to the 3, or basically 8. And slash slash is floor division, which is basically what's the integer result of a division. 5 divided by 2, 2 goes into 5 twice. There is some remainder, but slash slash just gives me the 2. Okay? Those are basically my math operators, and I can go to town with them in any Python program. Sort of a, I guess, a cool kids type of part of Python is we've got assignment operators. So if I stick the value 5 into x, fabulous and wonderful, then if I do x plus equals 3, what I'm really saying with that statement is x equals 5 plus 3, which comes out to be 8. If I do x minus equals 3, what I'm really saying is x equals 5 minus 3, which comes out to be 2. So it's just a shorthand notation. And the reason we have a shorthand notation is because you do x equals x something something else so often that they gave us this shorthand notation that just makes it a tiny bit easier for us to write these statements. So I just want to give you a heads up that they exist in case you happen to see them. All right, fabulous. So I'm running my program, everything's going on, but I want my program to ask me questions. I want to be able to give input to my program so I can control what it does. Not a problem whatsoever. So let's talk about how we do that. When a program asks for user input, it really should tell them what it's asking for. And so that's exactly how Python's set up. So you'll see a statement here, first equals input, left paren, double quote, enter your first name, double quote, right paren. What's going to happen is on the screen, it's going to print, enter your name, and then the program's going to stop. It's going to wait for you to type in your name. When you hit enter, whatever you've typed in is going to be placed into the variable first. Okay? So the input statement is how Python reaches out through the keyboard, gets input from the user, and then places it into a variable. Input function displays the string. I think I have an example for this. So let me just do a quick double check. Oh my goodness, I have variables too. I forgot to show you that. Oh my goodness, I have all sorts of stuff, but that's fine. We'll cover up this real quick here though. Come on, show me some variables. So here we go. So I apologize, I meant to show you this. So my int equals 5, my real equals 7.3, my string equals double quote, happy birthday, double quote, and my Boolean equals false. And then I have a print of my int, my real, my string, and my Boolean. I say, well, let's run it. Let's see what we get here. Dun, 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 dun. There we go. 5, 7.3, happy birthday, and of course, false. All right, so that's good. So we've got variables. We just load values into them, ching, 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 ching. And then anytime we hit a print statement, we get their current value to be displayed. Now also I had some logical operators here, so let's take a look at these. What was this? Print, double quote, true plus true, and then I do true and true, and we'll get a result from that. Either it'll be either true or false. We have true and false, so true and false, and then we have true, and we have true or false. That would be fine. And then down here we have not true. Well, let's run this one and see what we get. So when we do true and true, it comes out to be true. So that's the result of an AND operation. When we do true and false, the result, of course, is false. Because remember, for an AND operation, you need both of the arguments to be true. Now we're down here with true or true, turns out to be true, of course. True or false, of course, comes out to be true, because all you need is really one of those to be true. You know what I really probably should have done, and this would have been better, so let me just go ahead and do it quick. How about I can do this? Did I cause it to lock? A little bit. Come on. I'm not going to spend a lot of time on this. There we go. Let's try running this again. Now that I've done my clever on-the-fly add. Alright, let's try it. It turns out that I felt that I needed to have one more example. We expected... Oh, there's sample input. Okay, great. So user value equals input. Enter a number between... Oh, I know exactly what this is. I jumped ahead a little bit. I apologize. We'll get to that in just a moment. So this is numerical input. So a little trick to Python, well, I don't know if it's a trick, or maybe it's more of a characteristic of Python, is that when you get something from the keyboard, it always comes in as a string. Okay, so what does that actually mean? Well, if I ask the user, for example, how old they are, and they tell me how old they are, I'm going to get a number from them, but it's going to come to me as a string, really a collection of characters. Python won't see that number that they entered as a number. I'll see it as a collection of characters. And what that means is that I have to convert that collection of characters into a number, which isn't really that hard. So here's an example. Num bottles equals input. Please enter the number of bottles. They'll enter like 100 bottles or something like that, and that'll go into num bottles. So num bottles contains the string of characters 100 if they entered 100. Then I can say int and pass it num bottles, and Python will say, oh wait, num bottles is a number, so it will convert those characters 100 into a number 100 and place the number into bottles. Likewise, if I'm going to get them to enter a number that has a decimal point in it, I can say enter price per bottle. Once again, that string will be placed into bottle price, and then I can do float and give it the string bottle price, and Python will convert that string into a number 2.65 or something like that and place it into price. So it's a little, gotta be aware that every time I get input, it's always going to come in as a string. Here's my sample program. Write a program that reads a number between 1,000 and 99999 from the user when the user enters a comma in the input, then print the number without a comma. Here's a sample dialog. User input in color. Okay, that's great. And this is actually what my example was. So let me see if I can just zip to my example here real quick. So user value equals input, enter a number between 1,000 and 9999. Okay, so I'm going to get them to enter what they're going to do. It's going to go into my variable called user value. Remember, I'm going to have a string in there now, right? So I don't actually have a number. It's going to look like a number, but it's not a number. Then I'm going to say for index in range 0 to the size of that, so how many characters there are, and we'll get to this in a bit, but I'm jumping ahead. I'm cheating here a little bit. If the character in user value is equal to a comma, don't print it out. That's what the not equals to, right? Not equals to. So if it's not equal to a comma, go ahead and print it out. If it is equal to a comma, don't print it out at all. So I'm going to go stepping through whatever they entered as a number, and if I find a comma, I'm not going to print it out. So let's go ahead and run this one and see what we get. Just a trivial little program, just showing that when we get input, it comes in as a string, and we can process it. All right, here we go. I'll put in, what, 10,000? Note that it has a comma in it, right? And when we print it out, because we went stepping through it, we found the comma, and if there was a comma there, we did not print the comma, we can print out 10,000 without a comma. No big deal, just showing that it can be done. Now, that's all about input. So let's talk about output now, right? The format method was added back in Python version 2.6. Format method of string requires a little bit more manual effort than just doing a print, okay? The user is going to put a squiggle where they want a variable to be substituted, and they can provide a detailed formatting directives, but the user needs to provide the information that they want to have formatted. Okay? Method allows us to concatenate elements within the output through positional formatting. Basically, we can move things around. So here's a quick example. I'd like to write a program that's going to tell the world that my name is John Smith. I happen to own 27 televisions. I have no idea why, and I'm currently 4/5 of the way done with my college education. Okay, so 3 things I want to print here. My name, John Smith, number of televisions, 27, and how far through college I am, 4/5 of the way. I'm going to store my name in a variable called name, store the number of televisions that I own in a variable called televisions. Okay, cool. And apparently I'm not going to store the 4/5. One way I could do this, and this would work, print double quote I am, then name, I own televisions, and I am 4/5 of the way through college. That is workable Python, but my goodness, that's ugly. And what a pain in the butt if I have to make changes. That's just going to be ugly to change. There's got to be a better way, and there is. Here's a better way. I can do print I am squiggle 0, I own squiggle 1 televisions, and I am squiggle 2 of the way through college. Then I follow that print with a dot format, and I list out the 3 variables that I'd like to have printed: name, televisions, and the value 4/5. Name will get stuck in where the squiggle 0 is, television will get stuck in where the squiggle 1 is, and 4/5 will get stuck in where the squiggle 2 is. Now what's cool about this technique is I can also do this. Print I own squiggle 1 televisions, I am squiggle 2 of the way through college, and I am squiggle 0. And my format statement doesn't have to change at all. Name televisions and 4/5 is perfectly fine. Didn't have to change that. I moved my squiggles around. I think that I have an example here. Formatted output. That'll do it. So here we go. Name is equal to John Smith. Remember, name is a variable. I just stuck John Smith in there. Televisions equals 27. I'm putting the value 27 into television. Now I'm going to do the print I am, name, I own. I've got to turn it into a string. Televisions, and I am. Got to turn it into a string 4/5 of the way through college. So that'll work. There's no problems with that, but it's ugly. But here we go. Here's a better way. I am squiggle 0, I own squiggle 1, and I am squiggle 2 the way through college. Dot format name, televisions, and 4/5. Now I change everything around. I own squiggle 1 televisions, I am squiggle 2 the way through college, and I am squiggle 0. Remember, so I basically reformatted the string I wanted to do, but I make no changes to name, televisions, and 4/5. So let's give this one a run, see what kind of output we get. So the first line works perfectly. I'm John Smith, I own 27 televisions, and I'm 0.8 of the way through. That's fine, but it's super ugly. The second one works perfectly also. John Smith, 27 televisions, 0.8. But man, that's a lot cleaner. It's a lot easier if I have to come back and make changes to it. And the final one, I own 27 televisions, I'm 0.8 of the way through college, and I am John Smith, where we just basically moved the squiggles around, worked perfectly also, and we didn't have to touch the format part of it. So that's sort of a cool way to do output. Thank you very much, Python. All right, one of the biggest things that we always ask computer programs to do is to make decisions, okay? Essential feature of a program. What do we do when we come to a stoplight? Well, it really depends on what the color of the light is, right? If it's red, we'll stop. If it's green, we will go. And if it's yellow, we'll go really fast to make it through before it turns red. Well, okay, that's not necessarily true, but you understand the gist of it. A program can take different actions depending on inputs and other sorts of circumstances. How do we do that in Python? We use what's called the if statement. In Python, an if statement is used to implement a decision. When a condition is fulfilled, one set of statements gets executed, potentially, but not always. Otherwise, another set of statements could be executed. Here it goes. So, question is, hey, is the room that you're in too cold? Yes, it is too cold. Great. Then let's set the temperature in the room to 85 degrees. If the room is not too cold, then let's go ahead and set the temperature to 72 degrees. All right, well, that seems pretty good. So how do we actually go about doing that? So this is what an if statement looks like in the world of Python. So we have if floor is greater than 13, colon, because we need that for an if statement, then we will execute whatever comes next. Actual floor equals floor minus 1. Now, it's optional, but if we choose to include it, we can include an else statement. And the else statement is going to be executed if that condition of the if is false. So if it turns out that floor is either equal to 13 or less, then we would execute the else statement, and in that case, actual floor would equal to floor. I think I have an example here. So let's take a look. Here's my if statement example. I think. Come on. Here we go. So room temperature, I'm setting the variable room temperature to 68. Then I come here and I say, hey, if room temperature is less than 70, okay, so if it's cold, set the room temperature to 85. Otherwise, set room temperature to 72. So once I figured out what I want to set the room temperature to, I have a print statement that says the room temperature is set to squiggle 0 squiggle dot format, and then I set room temperature. So let's give this one a run and see what we get. I think we already sort of know what the answer is, but let's give it a shot anyway. Remember, I set room temperature to 68. So we're going to hit the if statement. It's going to say if 68 is less than 70, which it is, the room temperature is going to be set to 85. Yay! Okay? So the question then is, what happens if I change my room temperature to 80 and go ahead and run the program? So I'm going to come to the if statement. It's going to say if 80 is less than 70, and that's not true. So I'm going to jump to the else statement. I'm going to set my room temperature to 72, and when I print it out, it tells me the room temperature is set to 72. Whoop, there we go. All right, we're good. Notice something important when I did my if statement. Python uses tabs. And what that means is, back here in my program, notice that I wanted to execute this statement, room temperature equals 85, if this was true. So I had to indent it. Down here on the else, I want to execute this room temperature if the else is true. So I had to indent it, okay? Python requires block structure as part of its code. So how do you move over? You can put a bunch of spaces, or you can just hit tab, okay? With most editors, tab is exactly what you have to do. But basically, whenever you have a condition and a block of statements that you want to execute because of it, you're going to have to tab them all over so they're all nicely lined up. Here's an example. If total sales is greater than 100, then I want to execute the next 3 lines. Discount, total sales, and print. Okay? If I execute the else statement, then I've got 3 lines that I want to execute. The diff, the if statement, and then the else statement. So they all have to be tabbed over. That allows Python to understand the first 3 lines get executed if the total sales is greater than 100, and the next 3 lines get executed if you're executing the else statement. So tabs are a very important part of Python. In Python, and doing if statements and stuff like that, we do comparison operators. Key point here, equality is done by equal, equal. Okay, we got to remember that. It's 2 equals. That can fool you if you just put 1. Don't put 1. Exclamation mark equal means not equal. Less than, greater than or equal to, or less than or equal to. That's what we have. Relation operators are lower priority than everything else, so everything else gets worked out, and then we check on our relational operators. Here's our sample if problem, just real quickly. The variables fuel amount and fuel capacity hold the actual amount of fuel and the size of the fuel tank. If less than 10% is remaining in the tank, the status light should show a red color. Otherwise, it should show a green color. Simulate this process by printing out either red or green. I love these problems. All right, so let's take a look at our sample if problem. So here we go. So fuel amount equals 50. So we've got 50 gallons in there. The fuel capacity of the tank is 100 gallons. So if fuel amount by fuel capacity is less than 10%, we should print out status light is red. Otherwise, we should print out status light is green. So let's give this one a run and see what we get. Status light, so 50, so it means we're at 50% basically. Okay, that's cool. So what would happen if we popped that 50 down to 9 and ran it? Status light goes to red, which is good because 9 means we've got 9% and 9% is less than 10%, and so thus we would expect to see a status light red. So we see our if statement working correctly, and we see our else statement doing exactly what it's supposed to do in conjunction with the if statement. Mind you, we don't need the else statement. We could just say if, hey, is this true? If so, do something. Otherwise, let's just move on. Else statement is completely optional, but it's there if you need it. Now, there is a better way. There's a little extra that you can do with an if statement. In the world of Python, we also have a statement called elif, which effectively is else if. So if you do an if, you do a condition check and see, yeah, what the story is, and if it doesn't work out, you do an elif and do another check. So is your class score greater than 90? No. Hey, is your class score greater than 80? No. Hey, is your class score greater than 70? No. Hey, is your class score greater than 60? No. Eventually I get down to an S and get down to an else, and in the else I just say, forget it. I don't want to do any more comparisons. If I got here, then this is what I want to do, and bam, I just tell you got an F in this particular case. But elif means else if. And if an if condition is false, I can do an elif, which will test another condition to determine if something should be done. And it turns out this is super convenient, and it happens a lot. So Python supports elif. Now, if we want to do something over and over and over and over again in Python, we can use a while statement. A while loop in Python repeatedly executes a target statement as long as a given condition is true. Syntax is pretty simple. We say while, some expression, colon, and then whatever statements we want to execute. Statements can be a single statement if we want it, or it could be a whole bunch of statements. When the condition becomes false, then we'll jump to whatever came after the while statement. In Python, all the statements indented by the same number of character spaces indicate that they're part of the while statement. A very important component of the while statement is simply that it turns out you might never run a while statement. You might not run a while statement because the condition was always false. And if that was true, you would skip over it. I think I have an example of a while statement. So let's just take a peek here. I'm going to say num apples equals 10. I'm going to say while num apples is greater than 0, great, it's 10, so that'll be right. I'm going to print number of apples left, I just ate an apple, and then I'm going to subtract 1 from num apples using the really cool minus equals 1 format. Remember, that's num apples equals num apples minus 1. So if I run this, let's see what we get. Remember, num apples was set to 10, and my while condition is num apples greater than 0. Bam! It says 10 left, I just ate an apple, 9 left, 8 left, 7 left, all down to 1, and after 1, num apples is no longer greater than 0, so it stops. Chink. That's a while loop in action. Now, another type of looping technique we have is the for statement. And the for statement can be used to iterate over contents of any container, okay, any basically collection of characters, which is an object that contains, stores, or a collection of elements. So we say for letter in statement, state name. So Florida would have Florida, print letter. So we take each letter out, put it into the letter, and then we print them out. For loops are traditionally used when you have a block of code in which you want to repeat a fixed number of times. Remember, we had a while statement, and that was a little bit different. Python for statement iterates over the members of a sequence in order to executing the block each and every time. Loop continues until we reach the last item in the sequence. Chink chink goes like that. And I think I have an example of a for statement, so let's take a look here. I do. All right, let's take a look at it. Here's a for statement. For I in range 0 to 11, which is just going to produce the numbers 0 through 10. Print I, and then print all done when you're done with it. So let's give it a shot and see what it looks like. Bam, printed out the numbers 1 through 10, and I'm all done. Woo, look at that. Range function is part of it, so it's pretty simple. Range function just simply cranks out a sequence of numbers. In this case, I'd say range 1 through 10. The trick with range is basically that 10 says up to but not including 10. So 1 through 10 will produce the numbers 1 through 9. It does not produce 10. That's a little trick that can get you sometimes. Now, we got the for loop and the while loop. What's the difference between them? A while loop uses a Boolean test, and you don't know how many times it's going to do it. So it's a little bit of a mystery. It's good when you don't know how many times you're going to do something. But if you do know how many times you're going to loop, okay, we generally end up using a for loop. Okay, so we've got for and while loops, two different ways to do things. We use them under different conditions. Lists. Python's all about lists. So what kind of lists do you use in your life today? We've got shopping lists, we've got to-do lists, we've got Christmas lists, we've got lists coming out of our ears. In the world of Python, there's 4 steps that we go through to create a list. If I had IEEE Florida West Coast section and 2022 and I wanted to turn that into a list, first thing I would do is convert each of the names into strings by surrounding the data with quotes. IEEE in quotes, Florida West Coast section in quotes, and then 2022 not in quotes because it's a number. Then I would separate each of the list items with a comma, IEEE, comma, Florida West Coast section, comma, 2022. Then I would surround the list of items with opening and closing square brackets. Chink, 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 we're good to go. And then finally, I would assign the list to an identifier using the assignment operator equal. Bam. I'd have the variable called prerequisites, and I would set the list that contained IEEE Florida West Coast section in 2022 to it. Bam. I've got a list variable called prerequisites. Now, what does that look like inside my computer? Notice that you'd have a memory location where it would have IEEE, another memory location where it would have Florida West Coast, and another memory location where it would have 2022. Okay? Basically stores it in a list. Note that each location would have a number, 0, 1, and 2, basically an index associated with it. Now, once I've created my list, how can I get access to it? Good question. I will use that index value to get access to it. To access a list, you simply specify which index you want to use. That's done with the subscript operator in the same way you access individual characters in a string. So for example, if I had values equals that, 987654321, a list, I could say print values, square bracket 3, and it would print the element at index number 3. And I might have a list example, so let me just take a quick look here. I think I do. Come on. Oh, here it is. So values equals the list that consists of 98765432110, and I'm going to print values square bracket 3. So let's see, 9's at 0, 8's at 1, 7's at 2, and 6 is at 3. So let's run this and see what it tells us. show me what's in the list at location number 3. And it says, come on, come on, come on, come on, come, 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 come. Thinking, thinking, thinking. Well, I'm assuming it's going to tell me. There we go, 6, which is good because that's at location 3, just like we thought. So basically, here's our little list of IEEE Florida West Coast section. Prerequisite 0 would be IEEE, prerequisites 1 would be Florida West Coast section, and prerequisites 2 would be 2022. If we have a list that we've created, and the question is how many items do we have on the list, we can use the length, or len, function to figure out how long something is. So if I had a list, my list, and contained those 7 things, I could say list length equals length, my list, and I could print out list length, and I would get the number 7, because that's the number of items that are on that particular list. Now, a really cool thing I can do in Python is I can create multi-dimensional lists. A list can hold lists. When I do that, it gets crazy, right? So if I did multi-dim and I said 1, 2, 3, square bracket, 4, 5, 6, square bracket, and 7, 8, 9, square bracket, I've just created a multi-dimensional list, multi-dim, like that, which basically comes out and looks like this. First row is 1, 2, 3, second row is 4, 5, 6, and last row is 7, 8, 9. Lists are a lot more than simple arrays, okay? We come with a whole bunch of list methods. We already know about the built-in function called length, but it turns out there's more. Append, pop, remove, insert, and extend. So what do we got going on here? So here's append. So if I have a list, CHM 4025, chemistry 1 and 3, and I want to append Dr. Anderson in 2022 to it, I'll do the name of the variable, prerequisites, dot append Dr. Anderson in 2022, and it will stick Dr. Anderson in 2022 to the end of the list. I can also do pop. If I do just prerequisites dot pop pren, it will automatically remove the very last item on the list. If I do pop and give it an index location, 2 in this case, it will remove what's at location 2 in that list. Remember, CHM's at 0, chemistry 1's at 1, and 3 is at location 2. I can also do remove. If I do prerequisites.remove Dr. Anderson, Python will automatically search the list. It will find Dr. Anderson, and it will remove Dr. Anderson from the list. I can do insert. Insert requires me to say, where do you want to insert it? So index location 2, and what do you want to insert? I would like to insert the text phrase really hard. So I go back to my list, and at location number 2, I will insert really hard into it, and what had been there, which was 3, gets pushed to the end. I can also do extend, and extend allows me to add a list to a list. So if I have a list that contains Dr. Anderson 2022, I can extend the prerequisites list by adding Dr. Anderson 2022 to it. Basically just sticks the extra list onto the end of the existing list. I had an example for a dysfunctional calendar program, but we won't worry about it just because I probably don't have time for that. Let's talk about functions. So what is a function? A function is basically just a collection of code that I can call from my program. How do we do it? Well, we use the word def, then we give the function a name. Here we're going to call it cube volume, and we can send it parameters if we choose to do so. And then we indent all the code that we'd like to have as part of that function. So what happens when you call a function? So if I had a function called round, and I passed it the number 6.825, and I said I'd like to round it to 2 positions, it would go off somewhere to wherever round is, and it would go, oh great, 6.825. It would calculate 6.83, and then it would send 6.83 back to my program, and I would take 6.83 and place it into the variable called price. Now, multiple arguments can be passed to a function, and multiple values can be returned from a function. How do we create a function? Good question. When we're writing a function, we need to pick a name for it. We're going to call it select flavor. We got to define a variable for each argument if we choose to have any. In this case, we're going to send it yogurt. These variables are called the parameter variables. So put all information together, and we have def, the name of the function, select flavor, and the parameters that we're going to send to it, yogurt. And we have to, of course, put a colon at the end of it, because that's what Python's looking for. This particular line is called the header of the function. Okay? Basically, you see that we have our header of our function there, def, select flavor, colon. Anything that we want to have to be as part of that function, we have to tab and indent, and that'll create the body of the function. If we want to get something back from a function, we use the phrase return. So in this example, it was def get input, result equals 1. We do return result. We're going to send the value 1 back to whoever called us, which was answer equals get input. We were calling the function. We execute the function. We return the value 1. We will place the value 1 into answer, and we will print answer. And of course, we can return multiple values. We can return result and quantity. We just have to make sure that we have places to put it. Answer and amount is where the result's going to go. We will put those two values into those two variables when the function is done. Okay, final form of a particular function. Once again, we're a little bit out of time, so I'm not going to spend a lot of time on that. Order does matter. We have to define the function before we call it. That's what we see on the left-hand side. We define select flavor, and then later in the program, we do my choice equals select flavor. On the right-hand side, we say my choice equals select flavor, and then we define the function. Can't do that. Python's an interpreted language. It has to have seen the function before it can actually do anything with it. Functions and parameters, we can pass things to functions, basically. It's pretty straightforward stuff. We call those parameters, okay? Each one of the parameters gets dropped into the function, and it gets placed into what's called an argument variable. So when I'm going to call select flavor, I'm going to pass it yogurt. Yogurt's going to be going into it. And in that function, we're going to be able to use yogurt. And then we will return selection, will be the return call. And we'll place the return call into the variable called my flavor. Return variables, basically we can return either a variable or we could return a whole complicated expression if we wanted to. Either one of those works just fine. And in the world of Python, we just need to make sure that every path in a function is going to return something, no matter which one we do. All right, goals for the presentation were to introduce you to the Python programming language. We wanted to show you how you can install Python on your home computer, and I think we've done that. We wanted to explain how variables work in Python. We went over that. Explore how to get input and how to produce output from a program. We wanted to discover how to control program flow. That was our if statement. Introduce the concepts of a list and what can be done with it. And oh boy, we could talk about that for quite some time. And we wanted to explore functions and how they can be used to organize code. Whew, man, in an hour, I think we made it through all of that. We are now officially done. Yay! All right. Thank you so much for agreeing to spend some time with me tonight. I greatly appreciate that, guys. Hopefully you got something out of tonight's presentation. I enjoyed presenting it to you. I will make a recording of tonight's presentation on the Florida West Coast section. I will also make a copy of all of the slides that were presented tonight available on the Florida West Coast section. Yeah, give me about an hour or so to get my act together, and they should be up there later on tonight. All right? So fantastic. Thank you so much for joining me tonight. I wish you the best of evenings tonight, and have a very good time.